Dear friends, in this video, I'm going to discuss an interesting pricing problem for modeling. This problem has been sourced from a classic book written long ago titled Mathematical Analysis for Economists by R.G.D. Allen. And this has been adapted here for the purpose of discussion because it is very much suitable for spreadsheet modeling. We will obtain the solution using the optimization engine solver. Let me read out the problem. A radio manufacturer produces X sets per week at a total cost of X square upon 25 plus 3X plus 100. He is a monopolist and the demand of his market is X is equal to 100 minus 20 times root P when the price is P per set. How many sets should he produce? What price should he charge? So let me model this now. I designate P as the price, X is the demand, R is the revenue, C is the cost, Y is the profit. So price, demand, revenue, cost, profit. And in the yellow color, I put a trial value 1 as a starting point. And this is the variable cell. We will have to identify the optimal price that will maximize the profit. So I just enter a trial value. Doesn't matter, you can enter any trial value you like. Now, X is equal to demand is given by this equation 100 minus 20 times root P. So let me enter by a formula this expression and see what it is equal to 100 minus 20 star SQRT, the square root of price cell, which is this cell C2. I close the bracket and I get the initial value as 80. Now R is equal to revenue. Revenue is equal to quantity demanded, which is here, this cell C3, multiplied by the price. Therefore, this is equal to this cell C3 star, the price. That will also be 80 because the trial value is 1. Now, cost is equal to this expression, X squared by 25 plus 3X plus 100, but X is the demand. And therefore, what I put here is equal to this cell star this cell, meaning X squared, sorry, this cell, again C3 only, divided by 25. And I put a bracket here carefully to make clarity. Another bracket, outer bracket. I close this bracket inside inner bracket. Plus 3 times X, 3 star X, which is this cell again. Mind you, we should put the cell because it's a formula. Plus 100. I close the bracket. Now, what I get is 596 as the cost, which is, of course, based on the initial value. Now, Y is equal to profit. Profit is equal to revenue minus the cost. And a negative number appears, doesn't matter, it's a trial value. Everything we have entered by the formula except this cell price, which is to be varied, we put number 1. Now let's move to solver, data solver. Let's model this now. The target cell is the green color, profit. Maximize this. The changing variable cell is the price cell. and apparently there are no constraints, and GRG non-linear by default, it appears GRG non-linear because the profit is non-linear in nature, and simply leave the rest. Solve. Solver found a solution. All constraints and optimality conditions are met. Now we get price is equal to 14.228. So let's say price is measured in dollars, demand is measured in units. So $14.228, without loss of generality, I'm rounding it to $14. Otherwise, we can leave it as 14.23, whatever. I just put 14, charge a price of $14. Of course, the demand cannot be, the number of sets cannot be 24.559. So I round it to 25 sets. So the monopolist has to produce 25 sets, and the price he should charge is 14, and the profit is $349.43, approximately 350. Cost is 198, and the profit 151.63. I can just put 152, and this is the solution. Charge a price of $14. Demand is equal to 25 units, which the monopolist has to produce. Whatever he produces is the demand, and the profit is $152 rounded. And this 349.43, you can make it as 350 if you want to. 350 minus 198 is 152. It tallies. But we have solved the problem. Essentially, the idea is to understand the modeling. When it's a complex problem, we can, of course, use the first principles of differential calculus, but then this makes the job easier and we have understood. Thank you very much. We will see you with another interesting problem very soon.